So we've got all our shortcuts for finding triangles congruent. Now we're going to see why we want to get congruent triangles. So we're going to see how to use congruent triangles. So if you think back to when I first talked about congruent triangles, we said that if you have congruent triangles, then all the corresponding sides and angles are congruent. So it's going to work out a lot like our parallel lines. Once we could prove that lines are parallel, we got all those different angles. But with congruent triangles, once we have congruent triangles, we're going to get 6 congruent angles and 6 congruent sides. So that's a lot of information from just having one piece of information, you know, the one piece being that we have congruent triangles. So if we prove that triangles are congruent using any of these or hypotenuse leg, then we can say the corresponding parts are congruent. And the way we say that is corresponding parts of congruent triangles are congruent. So the corresponding parts of our congruent triangles are also congruent. We're going to abbreviate that Cpctc. Corresponding parts congruent triangles are congruent. So I'm going to go through just a bunch of proof examples using Cpctc to show you how useful congruent triangles can be. And it's also going to be a little more practice seeing how I prove triangles are congruent. So we'll start with this one. So my givens are SD is congruent to TC, SD, which would be this whole thing. Okay, so this whole thing here is congruent to TC, which is this whole thing. Okay, so those are congruent. CS, okay, this piece is congruent to DT, this piece over here. I'm trying to get angle SCT, so this, I'm trying to get this angle to be congruent to TDS, this angle. So what might help here is if we try to eliminate some of the clutter that's going on here. Okay, this is an angle in this triangle. So what I'm going to do is I'm going to separate that triangle, kind of bring it down here so maybe I can see it a little bit better. Okay, so on that triangle I've got this and this marked. Okay, I'm going to separate this other triangle out too so I can kind of see what that is. Just trying to make it easier for myself to identify what parts I have and what parts I might need. And on this one I've got this and this. Okay? So I see I've got two sides, so I'm thinking either side, 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 or side, angle, side. But this angle here, the included angle, is the one I'm eventually trying to get. So I don't think it's going to be side, angle, side. So maybe it's side, side, side. So I need these bottom sides to be the same. Well, this bottom side is going to be ST, and this one is ST, okay, because they're both here. So after my givens, all I really need to say is that ST is congruent to itself by reflexive. And then I've got congruent triangles by side, side, side. So triangle, let's see, this was C and this was D. So I could say, I want to say, let's see, S is the same as T. So I want to say STC would be congruent as the angle S here correlates to angle T here. So T would be the same as S, and C would be the same as D. So I've got these congruent triangles by side, side, side. I want to show that these angles are congruent, so these angles. Well, since these triangles are congruent, that means all their angles are congruent to each other. So S is congruent to T, this S is congruent to that T, okay, and this C is congruent to that D. Now, make sure, even though we drew these separate pictures, I'm not going to call it angle C, because really it's up here, and I'm going to need 3 letters to describe it. So I'm going to say the angle SCT is congruent to angle TDS because they are corresponding parts of these congruent triangles. So corresponding parts of congruent triangles are also congruent. So that's one example, and then I'll keep going and do a few more. I encourage you to try these examples on your own. Now that you've seen me do one, pause before each one, try to get through it. If you get stuck, maybe play just a little bit, see how I start, pause again, try to work through it, and that way you get more practice. All right, HJ is parallel to LK. JK is parallel to HL. Okay, so notice I'm using double triangles on here because these are parallel to each other and these are parallel to each other, so you want to have the same symbols. Okay, I'm trying to get LHJ, so I'm going to mark it in red just so I know which angles I'm looking for. LHJ, this one, I want that to be congruent to JKL, this one. That's what I'm working for. So what I think I'm gonna do is I'm gonna try to get this top triangle to be congruent to this bottom triangle. If I can get those triangles congruent to each other, then I can say these angles are congruent by Cpctc. So parallel gives me all those cool angles. So I can say that angle HLJ, okay, this one, is going to be congruent to this one because those are alternate interior. So HLJ is congruent to KJL. Okay, because they're alternate interior. I could also say, okay, so that's using these parallel lines. If I use the top and bottom parallel lines, then my alternate interior angles are going to be these two. So I could say HJL is congruent to JLK, also by alternate interior. So at this point I've got angle. All I need is one side. Any side will do. So I need a side on the top triangle to be congruent to a side on the bottom triangle. Well, they share this side, LJ. So that's going to be congruent to itself by the reflexive property. And now I've got congruent triangles. Okay, so LHJ is congruent to, so I went from L, which was the single mark on here, so J would be the single mark on my other triangle, to H, which is unmarked, so K is unmarked, to J, which is double marked, and L was double marked. LHJ, JKL. Okay, and this is by, oh, I didn't mark this here. This is angle, side, angle. Okay, angle, side, angle. Now, since I've got this triangle, I know everything on this triangle is the same as everything on this triangle, so these angles, okay, and I could just say angle H. I don't need the three letters on this one. It's congruent to angle K, because corresponding parts of congruent triangles are congruent. On to the next one. So remember, hit pause, try this one by yourself, and then come back and watch me do it. Put my line down here so I have room to write. QT is the perpendicular bisector of US. QT, so this one here, is perpendicular bisector. So it's not just perpendicular, it's also a bisector. So that means I'm going to have right angles here. Okay, both of these. So I'm going to write all that information down. So I'm going to say that. Oh, and just if you guys want to do this, okay, I'll kind of remind you. If you don't like writing three letters for your angles, name these angles 1 and 2. Okay, if you like that better. So I can say angle 1 and angle 2 are right. So that's the definition of perpendicular. Okay, it's also a bisector of US. So that tells me that these pieces are the same. So UT is congruent to TS. Okay, that's the definition of bisect. Okay, and that's just from one given. Our next given, QV is congruent to QR. So QV, which is here, congruent to QR, which is there. And angle VQU, this one, is congruent to RQS, this one. So now what I need is to get triangle QUV. So this far left triangle congruent to QSR, which is the far right triangle. So I'm going to need, it looks like if I could get QU congruent to QS, I would have side angle side. One way I could get those is to prove that these two inside triangles are the same. So that's what I'm going to work for. I'm going to try to get these two inside triangles the same. On the two inside triangles, I've already got a side and an angle on both. Okay, so I need to say that these right angles are congruent. So angle 1 is congruent to angle 2 because they're both right. Okay, technically it's a right angle congruence theorem, but both right is fine for now. So I need this other side here to get side angle side. So QT is going to be congruent to itself by the reflexive property. Okay, so I'll mark that. And now I've got side angle side for the inside triangles. So triangle Q at the top down to the right angle at T over to the other angle U is congruent to Q at the top down to the right angle over to the other side by side angle side. Okay, so now I can say that QU is congruent to QS. Because they're corresponding parts of congruent triangles, so they're congruent. Okay, so at this point I don't want to use any more dashes because I'm already up to 3. So I'm just going to use circles here. These are the same. Now I can see that I've got side angle side for my outside triangles, so I can say that they're congruent. So QUV is congruent to triangle QSR by side angle side. Okay, so that's using triangles, congruent triangles, to get other congruent triangles. So now what we could do is we could go back and prove why our perpendicular bisector construction actually works. Okay, so that's something I want you to think about, and I'm going to have you do that in class. So I will do one more proof for you. So again, try pausing and trying to do this by yourself, and then come back and see if you do it the same way I do it. Just so you know, the ways I go through these aren't necessarily the only right way. So if you have another way that works out logically, that's perfectly all right. So for this last one, I've got GH perpendicular to FJ. GH, FJ. So that's going to give me 4 right angles here. Okay. I've got GF congruent to HF. And angle 1 congruent to angle 2. I'm trying to get GJM, so I'm going to mark this in blue. GJM. I'm trying to get this angle to be the same as HJM, which is here. So I'm going to try to get either the left triangle congruent to the right one, or maybe I'll try to get this bottom left congruent to the bottom right, because these angles are parts of those triangles. So I can kind of see right now that this left triangle has a lot of information already on it with the right triangle. I've already got a side and an angle. And the last side to get side angle side is going to be FJ. So that's what I'm going to use. So I'm going to say that FJ is congruent to FJ by the reflexive property. Okay, so I've got this whole thing congruent to itself. So, okay, I'll kind of do it this way. Okay, so that's congruent to this one over here. Okay, same one. So on my left triangle, I've got side, angle, side, and side, angle, side on my other triangle. So I can say that these triangles are congruent. So I'll go G, F, J. That's going to be F, or H, F, J. My side, angle, side. And then I can say that these angles are congruent. By Cpctc. Okay, so I really didn't even end up using that perpendicular given. Okay, I didn't end up needing these right angles. I could have used them. You know, we could have said FM is congruent to itself. Then I'd have a hypotenuse leg for these. And then I could say, well, okay, well, that gives me these parts GM congruent to MH by Cpctc. What else would I have? Okay, and then I'd have reflexive here for MJ, and then I'd have side angle side for the bottom left and bottom right. Okay, so there's a longer way to get through this, but if you can kind of see the short way, that's a good thing. Okay, so I think you guys should be able to handle all the proofs at this point, so get started on those in your packet. Hopefully they go pretty smooth for you. I'm really hoping you guys are starting to get a hold of the whole proof thing. I think once we get the triangle proofs, you know, they start to make more sense on what we can and can't do, and why we've been learning all those other things, and it's more easy to apply our proofs this way.